Okay, so let's flip this game object by inverting the X scale rather than just doing the sprite flip part. So the first thing we need to do is figure out which way our character is facing. That's pretty easy because we know the walking direction based on our X speed, which is either going to be negative or positive number. So we can say if X speed is less than 0, then we know we're walking to the left. Else, if X speed is greater than 0, we know we're walking to the right. The other thing we need to do is check to see if we flip the scale already or not. So with an if statement, we can check two things. We can say and. So it's going to check if both these are true. And is a double ampersand. If you're doing or, we always called it pipes, but two of the line symbol. So we're going to say if my X speed is less than 0 and my transform.localScale.x is greater than 0. So basically, if I'm moving left and I'm facing the right, then what I need to do is flip this. The same goes for the other side. And here we just want to say if we're walking to the right, but we are facing left, so for less than 0, then we need to flip it. So how do we do a flip? Well, we essentially multiply, all these are vector 3s, they're vector 2 or vector 3s. We multiply this matrix. So we can ignore the z in this situation since we're doing a 2D game. So we can say transform.localScale times equals new vector 2 and we want to flip it on the x, right? So we'll say -1 on the x, and the y we don't want to flip, so we'll just keep it 1. So we can say transform.localScale times equals new vector 2 with the -1, 1. This should give us the result we want. You can see that this is kind of a repeat, so we could probably optimize this. But first, let's take a look and make sure everything's running. All right. We turn around now. That's great. Perfect. Good news. Oh, I'm sticking to I'll talk about side friction in a little bit too. See, I'm sticking to the walls here. Okay. One thing I'm noticing, and this is something that's sort of apparent, we should probably slow down the frame rate a little bit or speed Mega Man up. I think this is okay speed, so let's slow down this frame rate a little bit. He's going really fast. We can do that in the Animator. We just need to go, let's see, idle. I'd like to keep these all consistent. So let's say that this is maybe 0.8 of what it was. The run is 0.8. So we just knocked our speed down, our speed sequences down by a float. This seems a little bit better. Something else, I think I need to change. Let's look at the animation for run. I've got 3 frames. So actually this frame here is duplicated. So I'm going to copy it and paste it over here. That should make things look a little better. Oh, so much better. Here we go. Nice. All right. So I guess we can come back and optimize this a little bit, right? I think the main thing is that we can do an or, like I mentioned earlier. So let's we're going to sort of separate this into brackets and then say or. And then we've got this case, and we can take out this whole else block. So our code's getting a little bit longer, hopefully not too hard to read. But we're basically saying if this is true or this is true, do this. And let's see, I think the result should be the same. Cool. One thing you might also be seeing is Mega Man still has like a little bit of run as he's slowing down. We could make that a little bit sharper. In older games, you're either going or you're not going. By default, Unity is looking for analog input from the axes. So if you have an analog controller, you could make. Oh, I have an analog controller. I can make Mega Man go a little bit slower or full speed. Right? It's taking analog input. In most games, this is what you want. That's why it's the default. But for our retro style game, let's get rid of that transition part, and we're just going to go for the raw input. And it's a pretty easy change. Just right now, we're saying get axis. We just say get axis raw here. And that's going to turn this from a float to kind of like all or nothing. It's going to be 0, -1, or 1, rather than some number that's in a range in between. So now let's see. Yeah, at full speed, I'm stopped. At full speed, I'm stopped. Perfect. This matches our game aesthetics a little bit better. So next we need to do our jump. And we can't just drag a single sprite on to automatically make the animation. We could select multiple and then delete one. But I'm just going to show you a different way to just make a new animation. I think we can just say create and create animation. And let's just call this jump. Great. And let's open it. It doesn't have anything in it, but we can take our jump frame and I have to be on the player. I need to associate jump with the player. So let's drag jump on. Cool. Now I can select jump, which is empty, and put a sprite on there. Great. And now in our animator, we have jump. So now we have a situation where we need to be able to go to jump from a run and to jump from an idle. So 2 different scenarios. So let's make transition and make transition. This jump animation, we want it to trigger whenever we're not touching the ground. So this is going to be a Boolean. It's going to be either true or false. We'll either be jumping or not jumping. So I'm going to make a new parameter here. I'm going to make a Boolean, and I'm going to call it grounded. So if grounded, let's go in here and get rid of our exit time and stuff. So if we're jumping and we're grounded is true, then we want to be an idle. And if we're an idle, but grounded is false, then we want to be jumping. If we're running and idle is and grounded is false, and we also want to be jumping. Great. And you notice I didn't make a transition from jump back to run. This should automatically happen. If I get to idle and I'm moving, idle will automatically move into run. So I can kind of save on some extra logic right there. Okay, so this is set up, and now we just need to decide when we're setting this grounded parameter. So to do that, we need to get into code, and we have a jump, but right now it's a double jump, right? We want to jump only when we're on the ground. So for that, we need to do an overlap circle. This is something that we talked about a little bit doing shooters, but uh, we also use it for platformers to tell if you're on the ground. So I'm going to make a boolean here. I think I'll make it public actually, so I can look at it. Public bool grounded. So the overlap circle takes 3 parameters, at least that we're going to use. And so I'll define them here right after grounded. So it takes a point where it expands from. So basically its center. It takes a radius and it takes a layer mask. For the center point, it's just easier if I reference a child of the game object. I'm just going to call it feet point. So I'm going to say public feet point public transform feet point. And next I'm going to make the layer mask. I'm just going to call it ground layer. Cool. So now that we have those, let's associate them over in the editor. So I'm going to say create empty child. So now we have our feet. And it's just an empty game object. Because of that, we can't really see it. So I'm going to give it a label, feet right here. Let's put the feet where the feet go. If you have a character, you can just kind of eyeball about where you want that to register. And my player is just a scale of 1, so I think my radius would be 0.5. Okay, so the feet are there. Let's create the ground layer for all of these things. So right now we have, let's open this prefab. And right now it's on the default layer. Let's add a layer called ground. Just going to put in the first empty slot. And now I can select it. Cool. So now all these platforms are on the ground layer. The next thing is in my code, let's drag the feet into feet point. Great. In this ground layer right now is nothing. Let's select ground. So now this layer mask is only going to look for these things on the ground layer. And that's exactly what we want. Let's hop back to our code. So in front of jump, let's say grounded, which is our Boolean we defined, equals physics 2D dot overlap circle. And first we need a vector too, so that can be our feet point dot position, where we dragged that child object. And then next is our radius, which I'm going to guess is 0.5. For you, just like test it out, see how well that works. And then our layer mask is going to be ground layer. Ground layer. Great. Okay, and now we just need to add a conditional in here. We don't want to just jump whenever we want, right? We don't want to have infinity jumps. We want to only jump when we're grounded. So I'm going to say and grounded. So those 2 ampersands. So physics 2D overlap circle. Like I said, it works sort of like a raycast, only it's a circle instead of a line. And doing these calculations, it's going to look based on this center point and this radius. Is there anything on this layer within that radius? And if so, it's going to return true. So we have this Boolean that we're assigning this math, and if it's true and you hit jump, then you're allowed to jump. Otherwise, you're not allowed to jump. The next thing we want to do is, now that we've kind of constrained our jumping, let's set that animation that we set up. So I'm going to say animator dot set bool, and this is grounded, our animation parameter grounded, and we're going to set it to grounded our Boolean that we just defined. So this should be able to trigger our jump animation. I shouldn't use the word trigger. Should be able to set our jump animation whenever we're in the air to look correctly, and then put us back into our standing or walking whenever we're on the ground. So let's try that out. So I'm falling, jumping, good. And if I hit it a bunch of times, I'm not multiple jumping. So this is great. Now let's, there's just a couple more changes to make. So right now we talked about, you know, maybe sometimes you want to have a platform where you have to jump over it, but a lot of times in games, you can just jump in front of a platform. We also have this issue of side friction still. Let's see if I can stick to this. Yeah. So we want to get rid of both of those. So in Unity, there's a thing called a platform effector. And let's use this guy as an example. So I'm going to say add component platform effector 2D. And it gives me this warning that I need to use used by Effector over in my box collider 2D. So I just need to check this box, and then the warning goes away. And the things to look out for are use one way, which this, depending on what is up, and you can see this radius showing me what direction is facing up. This will let me, use one way lets me go through the collider at the bottom, but hit it at the top. The other thing is sides, use side friction, make sure this is off, and that'll make it so you don't stick to the sides anymore. So let's check this out. So now, like with this one, I can just go behind it or in front of it. I can go pass through it, but not when I fall. Unlike this one where I hit my head. The other thing is I can't stick to the side here anymore. Side friction's off, even though I can still stick to that one. So these platforms are kind of more like what we want. Now, here's the thing. Because we're using add force, I can spam it, and I can add to my velocity when I'm jumping through things. So we have to add one more line to sort of reset our jumping movement. And what we're going to do is just reset the velocity before we add the force. This is going to be good for us if we decide to do double jumping or something in game. It works a lot better if you reset the velocity. Equals new vector 2. And we know y is going to be 0. We want to reset y. But x we need to inherit because we don't want to screw with our back and forth direction. So I'm going to say rigidbody.velocity.x for the x side, and then comma 0 for the y side. So every time we hit jump, our x should stay the same, and our y is going to be set to 0. That will fix our crazy acceleration issue that we're getting from this. So now we only get, if we hit jump right here, we only get our normal jump. We don't start accelerating.